Okay, today's lesson is going to be over solving inequalities using multiplication and division. So before we solved inequalities using addition or subtraction, now we're going to use multiplication or division. The only difference between multiplication, division, and addition and subtraction, really the only difference between multiplication and division when in relation to solving normal equations is if you have a negative number that you multiply or divide by on each side of the equation, you end up flipping the inequality sign. So we'll go through a couple of examples and just test these out. So in this situation here, we got x divided by 4 less than 5. So remember, this side slash means a fraction. So x over 4 is less than 5. Nothing changes when we go to solve this inequality versus an equation. Inequality sign doesn't make any difference. We still need to get x by itself. So we're going to multiply by 4 on both sides. Multiply by 4 here. And our answer ends up being x is less than 20. Then we do the same 3 steps that we've been working on. All right, we're going to write the corresponding interval notation. So if x is less than 20, that means 20 is the greatest number. So 20 is the biggest number. And the smallest number, well, if x is less than 20, any number less than 20 works. So 19, 18, 17, 16, so on and so forth, all the way to negative infinity. This we can't equal 20 because there's no equal sign here. So put a parenthesis and a parenthesis here. Then we got to write the number line, so we'll draw the number line here. Mark 20 on the number line. We got to use either an open or a closed dot here. Well, in this case, it's not equal, so we'll use an open dot. I'm going to mark 19. I'll mark 21 here. And we got to shade it. In this situation, we're going to shade it to the left side toward the negative numbers. And then finally, we need to draw a graph. So I'm going to draw a little graph here. And then we got to mark 20 on our graph. Because we're using an X, that means it's a vertical line. So if I mark out here 10, 20, we got a vertical line. It's dashed because it can't equal. And we're shading to the numbers for x that are less than 20, so we're going to shade to the left side. All right, that's our first example. Now we're going to go into an example where we have a negative number on the bottom. Okay, this is the only difference between solving an equation and solving an inequality. When you have a negative number and you have to multiply by a negative number to this side and to this side, what happens is the sign needs to flip. And this may be kind of confusing for you, but let me try and clear this up. Let's say that, for instance, we have something like 1 less than 2. Well, if I multiply by a negative on both sides, a negative 1 on both sides, that would end up giving me negative 1 less than negative 2. But we know that negative 1 is not less than negative 2. Negative 1 is actually bigger than negative 2. So that's why we have to, instead of doing that, we have to flip the sign to keep the inequality true. So we can all agree that 1 is less than 2. But if we multiply both sides by a negative number, all right, now this becomes negative 1, and negative 1 is actually bigger than negative 2. So that's why we have to flip the sign there. Same thing can be said if we have, like, let's say we have negative 3 is less than negative 2. This is true. All right, but if we multiply by negative 1, we end up with 3 on this side and 2 on this side, and we know 3 is actually bigger than 2. So 3 is greater than 2, and you notice the signs flip there. So whenever you multiply by a negative or divide by a negative on each side, it flips the signs. So coming back to this problem here, we multiply by negative 6 on both sides. This cancels and we're left with an x, but the sign flips. So it's now greater than or equal to negative 7 times negative 6 is 42. So the sign flips, less than or equal, flips to greater than or equal to. That's the only difference between equations and inequalities. Now we're going to go ahead and draw the number line and do the interval. So the number line, I guess we'll do first. 42. X is greater than or equal to it, so it's closed dot. This is 43. This is 41. And so we're going to shade it toward its solutions, which are to the right. We can go ahead and write the interval notation. The interval notation for this problem here would be 42 is the smallest number, and it can be equal. The biggest number, well, 42, x is greater than or equal to 42, so the biggest number is going to be infinity. And then finally we need to graph it. So x greater than or equal to 42, if we graph it, let's see, 42, we'll just mark it out here. 42 would be out here. We got a bold line at 42. So we got to shade it greater than or equal to. The numbers that are greater than are this way. We shade it to the right. All right, let's talk about division now. So we did multiplication. Let's talk about division. Nothing changes now. We got 7x greater than 56. We're going to divide by 7 on both sides. So x is greater than 8. We're going to go ahead and do the interval notation. So x is greater than 8. That means 8 is the smallest number. So 8 is the smallest, and infinity would be the biggest. It can't equal 8, so we have a parenthesis there, and we have a parenthesis for infinity because it can't equal infinity either. Now we're going to use the number line. Let's draw the number line here. Let's mark 8 in the middle. So, open or close dot? Well, we've got an open dot because it can't be equal. And let's mark 7 and 9 right here. So x greater than 8, we're going to shade to the right side. And then finally we're going to draw our graph. X is greater than 8. Well, in this case, we're going to mark out here 8. Let's see. We'll go up by 4s. So 4, 8. It's a dashed line because it's greater than sign. So dash vertical line. X greater than 8, we're going to shade to the right side where x is greater than 8. Now we're going to do the same thing, but this time with division. So remember, we got a negative number here, so we're going to divide by a negative 4. Remember, when you divide by a negative, it flips the sign. So divide by negative 4, we get x less than or equal to 35 over 4. Well, we could reduce that. Actually, we can't reduce that. We're just going to leave it as negative 35 over 4. Well, we can go ahead and still do our interval notation. So negative 35 over 4, if x is less than or equal to it, that has to be the biggest number. The smallest number would be then negative infinity. Well, greater than or equal to means we could equal this number, but we can't equal this number. Now we're going to graph it on a number line. So negative 35 over 4. Just to make this easy, I mean, I know 35 over 4, 35 divided by 4 is going to be some sort of, I don't know, maybe it's like close to 9. I'm just going to put something out here like negative 100, just to be sure that this number is smaller. And I'm going to put 0 out here just to be sure this number is bigger. Open or close dot here, we're going to go with a closed dot because it could be equal. And it's less than, x is less than, so we're going to shade toward the negative 100. And then finally we're going to graph negative 35 over 4. I'm just going to mark out here and write negative 35 over 4. And I have a bold line going through that point. And if x is less than or equal to negative 35 over 4, well, the positive numbers are this direction, so I need to shade away from it. So I'm going to shade to the left side. And that's how you solve inequalities using multiplication and division. Don't forget to do the U-try problems.